Hello, I am G. Rajesh, Assistant Professor, Department of Mechanical Engineering. I am going to talk about the course MED 3212 Additive Manufacturing. So, in this lecture, we are going to focus on the liquid based additive manufacturing systems. The first system that we are going to see is called as the stereolithography. So, it is the first ever commercial rapid prototyping system which was resin based came into existence. It was called as the stereolithography or SLA. The resin is a liquid photosensitive polymer that cures or hardens when exposed to ultraviolet radiation. This technique involves curing or solidification of a liquid photosensitive polymer through the use of irradiation light source. The source supplies the energy that is needed to induce a chemical reaction, which is called as a curing reaction, and the body of large number of small molecules forming a highly cross-linked polymer. So finally we get a solid kind of surface from liquid. Now we are going to delve deeply into the process of stereolithography. The ultraviolet light comes from a laser which is controlled to scan across the surface according to the cross section of the part that corresponds to the layer. We know that in additive manufacturing, which is also called as a layer-based system, we will slice the part into different layers and we are going to manufacture it layer by layer. Here, the details of a particular layer is sent to the laser light, which scans the liquid accordingly. The laser penetrates into the resin for a short distance that corresponds to the layer thickness. The first layer is bonded to a platform which is placed just below the surface of the resin container. The platform lowers by one layer thickness and scanning is performed for the next layer. This process continues until the part has been completed. Now you are seeing the stereolithographic part. So you can see that a complex shapes are also possible. The orientation of the part can be according to the requirement. So it is not compulsory that the part has to be always kept in a vertical or an horizontal direction. Thus, the stereolithography produces the part from a liquid resin by means of photosensitive reaction in which the solid is formed from a liquid. Okay, so the liquid actually solidifies to our required shape. So advantages. So we can get at the round the clock operation. The SLA can be continuously used unattended. So here the computerized process is well supported. We can achieve very good build volumes from small to larger number of parts. So whichever the size of the container, we will be able to produce a part which is somewhat smaller than that. The accuracy is very good. The surface finish is obtained is one of the best because the laser scanning is very thin. Small little layers solidifies, creating a better surface finish. The wide range of materials from general purpose to specific applications can be manufactured using this stereolithography. One of the main disadvantages is that it requires support structures. The overhanging parts cannot be as such made. We need support structures to support them. So it requires the post processing, which involves the removal of the support structures and unwanted materials, which can be tedious and time consuming. So if not done properly, it may also damage the model. So post curing may also be needed to cure the object completely to ensure the integrity of the structure. So post curing improves the strength of the part produced. So here we can see a setup of the stereolithography. You can see a mat over which the resin is placed, and there is a platform which can be raised by means of an elevator up and down. There is a wiper that moves horizontally from left to right as well as along the y direction. So the laser light can move according to the profile. So when the laser light comes in contact with the resin immediately solidifies. Thus, the part layer is built one after the other. The applications are models for conceptualization, packaging, presentation, prototypes for design, analysis, verification, the prototype tooling for low volume production, patents for investment casting, sand casting, modeling, tools for fixtures and tooling design, and production tooling. Now we are going to see the next liquid based system that is called as the solid ground curing. So it is also one of the important liquid based systems. So it can be best understood when we look at all the process simultaneously. So here what we are going to see is that the image of the layer is produced by using a toner on a glass plate to create a photo mask. A thin resin layer is applied onto the flat workpiece. The photo mask is placed above the workpiece and both are aligned under a collimated UV lamp. The UV light is turned on for a few seconds. The part of the resin layer is hardened according to the photo mask. The solidified resin is removed from the workpiece. Melted wax is spread into the cavities created and hardened. The layer is milled to achieve a smooth and a precise height. The workpiece travels under the powerful longitudinal UV lamp for final curing of the layer. New resin is applied and the whole process once again is repeated. So we have discussed the steps from 1 to 9 and they will be continuously repeated and we will get the final part. So advantages are parallel processing. The process is based on instant simultaneous curing of the whole section of the layer. It is high speed. The production cost can be lower, about 50%. So it both saves both time and cost. Self-supporting. So it has a solid modeling environment. The solid back supports the part in all dimensions. Therefore, support structure is not required. So that is an important feature. Support structure not required. The fault tolerance good. So it is removable trays allow the job changing during a run and layers are erasable. So unique part properties can be obtained and the shrinkage effect is minimum. It has a high structural strength and stability and there are no hazardous orders are generated. The resin stays in a liquid state for a very short time and the uncured liquid is wiped out. So it is more safe. So the main disadvantages are that it requires a large physical space. Sometimes the wax gets stuck in the corners and the crevices. A lot of waste material is produced and the whole system is noisy. Applications are so it can be used for producing the conceptual design presentations and for engineering testing integration into the design. It is also used for tooling and casting applications, mold and tooling, and medical imaging. So you are looking at the parts that can be produced using the solid ground curing.